So we are officially starting chapter 5. We took last week to kind of review our exponent rules. We are going to have to use those rules throughout the chapter 5. So we're going to be working with, in the first section, polynomials. Guys, I'm telling you right now, I feel like I have taught you this lesson 5 times already this year. Everything I do today should feel very, very familiar, except now we're going to use this fancy name, polynomials. But I'm telling you, you've been working with polynomials all year long without calling them polynomials, all right? So I want to start with a few definitions now that we're going to throw this fancy word at you. If you're going to start with polynomials, you have to start with what's a monomial. So let me start there. A monomial can be a few different things. A monomial can be a number. So like 8 or negative 53 or 2/3. Those are numbers, right? Those are considered to be monomials. A monomial could be a variable. So it could be x. It could be y to the 4th. It could be z squared. That's a monomial if it's just a variable. Or it can be the product of a number and a variable. So if you multiply a number and a variable together, that creates a monomial. So like 7x, or negative 4x to the 3rd, or 10xy to the 5th. Those are all monomials. So guys, if you notice, a monomial has no addition or subtraction. Everything's attached by multiplication, okay? And if you ask me, a monomial looks like a single term of a mathematical expression, right? If you think about these expressions that we've been working with, x squared plus 8x minus 7, all of these monomials, they look like the individual pieces of a mathematical expression, the individual terms of a mathematical expression. And guys, that's exactly what a monomial is. It's a one-term mathematical expression. Okay, so now that you know what a monomial is, let me tell you what a polynomial is. Let me just move all this up. So guys, a polynomial can either be a monomial, so it can be a single term, it can be a number, it can be a variable, or it can be the product of a number and variable, or it's going to be the sum of 2 or more monomials. So guys, all of these are polynomials. So they're basically mathematical expressions, and you've been working with mathematical expressions all year long, except now we're finally going to call them not just an expression, but a polynomial expression, okay? So the word polynomial itself, guys, it literally means many terms. Poly means many, and nomial means terms. So if you're going to add 1 or more terms together and create this mathematical expression, it's more than likely a polynomial, okay? So when you first got introduced to polynomials back probably in 8th or 9th grade, you used to classify polynomials by the number of terms. So guys, do you remember a 1-term polynomial was a monomial? This is a 2-term polynomial. We call that a binomial. This is a 3-term polynomial. We call that a trinomial. Do those words ring a bell? Monomial, binomial, trinomial ring a bell with you guys? They should. Except now that we're in higher Algebra 2 level math, we don't tend to classify polynomials by the number of terms. We classify them by the degree of the polynomial. And the degree is whatever the highest exponent on a variable is. So guys, if you look at this 2-term polynomial expression, the highest exponent on a variable is 1. So we would call that a degree 1 polynomial, also called a linear polynomial, degree 1. This polynomial right here has 1, 2, 3 monomials, 3 terms, right? So that's a 3-term polynomial, a trinomial, if you will, but it's also a degree 2, because the highest exponent on a variable is 2. So we would call that a degree 2 polynomial, also known as a quadratic polynomial. All right, and then this is a polynomial that has 1, 2, 3, 4 terms, but it's also degree 3, because the highest exponent on a variable is 3. So we call that a degree 3 polynomial, also called a cubic, if you will, because when you cube something, it's putting it to the 3rd power. And then this is a polynomial that has 1, 2, 3, 4, 5 terms, and then it's a degree 4, because the highest exponent on any variable is 4. And that's what you're going to hear your book talk about from now on. They're going to talk about the degree of that polynomial expression. And the degree is just talking about the highest power on a variable, the highest exponent, okay? All right, so notice addition and subtraction are what separate each term or each monomial of a polynomial from the next term. So all of this adding and subtracting is creating a new term. That's a term. This is a term. This is a term, this is a term, and that's a term. It creates all these different terms that you are adding and subtracting together. All right, so it's kind of like polynomials, guys, you've been working with them all year, except now that we're in chapter 5, you're going to see some bigger polynomials. We're going to finally start looking at some degree 4 mathematical expressions or degree 3 mathematical expressions, where for the most of the year, we've worked with degree 1s or degree 2s, your linear and your quadratics, okay? All right. So it's almost like, well, if all of that is a polynomial, what the heck isn't a polynomial, right? Well, guys, the good thing about a polynomial is it keeps things nice and pretty. If it's going to get complicated or ugly, if you will, it's probably not a polynomial. A polynomial has things that it cannot have. If it has any of this in its expression, you can't call it a polynomial. So, guys, a polynomial can't have any negative exponents. Great. We don't want negative exponents anyway. It cannot have fractional exponents. Awesome. We all hate fractions. We don't have to have fractions. You can't have division by a variable in that expression if it's going to be a polynomial. If it has division by a variable by some unknown value, that's not a polynomial. It's an expression. It's a mathematical expression, but it ain't no polynomial. And then last, a polynomial can't have a variable under a radical. So you can't take the square root of x or the third root of y. You can't take some type of root of an unknown value. So basically, a polynomial takes all of this bad stuff out and doesn't allow it to be in its expression. So a polynomial is going to be a very nice mathematical expression. But it's going to get big. I'm not going to lie. It's going to get a big expression, but it's nice. All right? So if you look here, this is not a polynomial. It's an expression, but it's got a negative exponent. So we can't call it a polynomial. This one has division by x, a variable. Ain't a polynomial. It's just a mathematical expression. This one has the square root of x, a variable, not a polynomial. This one has a fractional exponent, x to the 1/2, not a polynomial. All right, so if you're going to be a polynomial, then you are a nice mathematical expression. All right, and then the third definition is if you're ever asked to write your answer in standard form of a polynomial, standard form means the polynomial was written where the terms are in descending order, which means it starts with the highest exponent and then works its way down to the just number. So guys, all of these polynomials are written in standard form, where it starts with the highest exponent, x to the 4th, then it goes to the x to the 3rd, then it goes to the x squared, then it goes to the x or x to the 1st, if you will, and then it goes to the just number, the constant. That is how you want to write your polynomials. You want them in descending order. Highest exponent down to the constant, the just number. All right, let's give it a go. Watch how you've been doing this all year already. So again, I feel like this is like the 5th time I've taught you this exact same lesson. So guys, we're going to work on operations with polynomials today. How to add them, how to subtract them, how to multiply them. But division of polynomials gets its own section because that's a little bit more complicated, all right? But here we go. Guys, if you're going to add or subtract, you're going to remove parentheses and combine like terms. We've been doing it all year, all right? So if we were asked to simplify the following expressions, guys, look at problem number 1. They want you to take this polynomial that has 1, 2, 3 terms and is degree 2, and they want you to add it with this polynomial that is also 3 terms and degree 2. But guys, you don't have to have 3 terms to add with 3 terms. It could be 5 terms that you're adding with 3 terms, and it doesn't have to be matching degrees. All you're doing is going to remove these parentheses and try to combine any like terms. So remember, like terms are variables and exponents the same. So x squareds can be added with x squareds. X's can be added with x's. Numbers can be added with numbers. X's to the 3rd can be added with x's to the 3rd. All right, so PEMDAS would say to do inside first because I don't have any like terms, so I can't add and subtract that. I go inside these parentheses, I don't have any like terms. I can't add and subtract that. So to get rid of the parentheses, distribute what's in front. Guys, there's a positive 1 assumed to be in front. If you distribute it, everything stays the same. 6x squared minus 2x plus 5. This parenthesis has a positive 1 in front. If you distribute it, everything stays the same. So negative 2x squared minus 11x and then minus 19. So you've broken everything out. Now we're going to combine like terms. Nice and easy. We've been combining like terms since chapter 1. So guys, we have 6x squareds, but you also took away 2 of them in the exact same problem. So how many x squareds do I have? I got 4. Now we're going to do our x's because we should be doing this in descending order. X squared should go first, now our x's. I had negative 2 x's. I minus 11 more. Now how many x's am I playing with? I'm playing with negative 13 x's. And now your numbers. I had 5. I took away 19. Now I got negative 14 as my number. And you're done. So I hope this feels really familiar. You might just have expressions, though, that have x's to the third and x's to the fourth. And maybe we haven't worked with anything that big yet, but it's the same concept. We distribute and we combine like terms. All right, guys, everybody's good here. Nice, feels like magnificently easy. Yes. Thumbs up at home. Everybody's good. We feel great about this. All right. I put this one in your notes because your homework, spoiler, I'm not giving you the homework tonight though, but on your homework tomorrow, they're gonna word problems like this. So I just wanted you guys to be prepared for it, where you actually have to set the problem up yourself. It's gonna say either find the sum is easy, you add, nothing happens with that. If they ask you to subtract though, they're asking you to subtract this 3-term degree 2 polynomial from this 3-term degree 2 polynomial. So guys, if you're going to subtract this from that, you have to have this first. So take this polynomial and write it down. 12x squared minus x minus 20. Then you're going to subtract this polynomial. But guys, in math, if you're going to subtract more than one thing, and obviously this has more than one thing, you have to use parentheses to make sure that you subtract all of it. So you're going to subtract all of the second polynomial. So negative x squared minus 7x and then plus 9. If you don't use the parentheses, you will be wrong. All right, so what you do is you bring the first one down, it stays the same. And then you have to distribute this negative 1 to get rid of those parentheses. So at the end of the day, if you distribute a negative 1, all of these change to the opposite side. So now this goes to a positive x squared, this goes to a positive 7x, and this goes to a negative 9. And now you're allowed to combine like terms. And when we go to combine like terms, you want to be in that descending order. Oh, Ian. Please yell at me, Mom. I'm not even thinking. I'm so sorry. Yeah, you should. I was like, stop. Now interrupt me. All right, now we combine like terms. X squared's first. I had 12. I added 1. Now I'm playing with 13. Now we do our x's. I had negative 1x, I added 7, or guys, think of it. You had 7, you took away 1, now you got 6. And then my numbers. I had the number negative 20, I minus 9 more, now I got the number negative 29. And there is your nice simplified expression. Okay? All right, so look at the last one for adding and subtracting. Now they want you to take this polynomial that has 1, 2, 3, 4 terms and is degree 3, and they want you to subtract this polynomial that is also 4 terms and is degree 3 as well. That's the highest exponent there. All right, I'm going to let you guys do this one first. So again, you should be looking, you can't do anything in here, you can't do anything in there, so distribute, get rid of your parentheses, and combine like terms. I'm going to give you a head start, and then we'll see if we're matching. Guys, all I want to say to you is, obviously, this leaves a lot of room for silly mistakes. You multiply wrong. You add wrong. Your sign is wrong. Take your time. Watch your signs. Don't rush anything, because that's when the silly mistakes happen. And now you're doing it twice instead of once. You want to take a peek to make sure we're all matching in the beginning. I distributed my 1 to the first one, everything stayed the same. I distribute my -1, and now all of those second signs change to the opposite. And then you're ready to combine like terms. X to the third should be first. And then check your answer with mine. I'm left with 4x to the third minus 12x squared minus 17x and plus 9. There is your simplified polynomial when you subtract those two. Everybody feel okay? We can do this all day, right? It's like, take a quiz right now, right? We've been doing this all year. Everybody should be good. All right. Well, the last thing we're going to do is multiply. But guys, you've multiplied also. It's literally FOIL or FOIL on steroids. It's just lots of distributing and then lots of combining like terms. And I just want to warn you, when you were doing the adding and subtracting, you literally just combined like terms at the end of the day. When you combine like terms, you don't change the exponents. You literally are, how many x squareds do I have? How many x's do I have? How many numbers do I have? But when you go to multiply, guys, don't forget, when you're multiplying, you multiply numbers, you add exponents. This is going to cause an exponent rule to be used. We have to use exponent rule number 1 when we are foiling. All right, so let's look at the first one, get you guys into the groove, and then you'll see how they just get bigger and bigger and bigger. So I figured I might as well start with a FOIL just to kind of get you guys feeling good again. Look at here, guys. They clearly want you to multiply these two parentheses together. There's no plus in the middle telling you to add them. There's no subtraction sign in the middle telling you to subtract them. These parentheses are literally attached, which means to multiply. PEMDAS would say do inside first, but guys, they're not like terms, so I can't combine them. They're not like terms, so I can't combine them. So the only way to multiply all this together over all of this adding and subtracting is to distribute. You take the first term in the first parenthesis, distribute him to everything in the second parenthesis. Then you take the second term in the first parenthesis and distribute him to everything over there. And that's how you multiply it all together. All right, here we go. 3x times 2x is 6x squared, right? 3 times 2 are your numbers. That makes 6. Multiply them. X times x is x to the 1 plus 1. Add your exponents. It's 2. All right, 3x times 5 is 15x. See how I've multiplied 3x with everything over there? I'm done with him. Now I go to the next term, the -4. I start distributing that. -4 times 2x is -8x. And then -4 times 5 is -20. And then it's the cleanup, combine like terms. 6x squared is the only x squared, so he stays the same. I had 15 x's. I took away 8 of them. Now I got 7. So see how now you're back to the exponents don't change. They don't change when you're combining like terms. And then -20 is my only number, so he stays the same. And that's how we FOIL. So guys, all of the multiplying is going to feel like this. It's distribution, except here, instead of distributing 4 total times, now look at this one. Now they want you to multiply these two polynomials together. So you're taking a 2-term polynomial and you're multiplying it with a 3-term polynomial. It just means there's going to be extra distribution. Here I'm going to distribute 6 total times before I'm done. All right, here we go. Take the first term and start distributing. 2x times 3x squared. That's going to be 6. X to the 1 plus 2 is 3. Add your exponents. That's 6x to the third. All right, now we go 2x times -x. 2 times -1 is -2. X times x is x squared, right? 1 plus 1, add your exponents. And then one more, we got to keep going. 2x times +7 is 14x. And now I have multiplied 2x with everything in that second parenthesis. So I'm done with 2x. Now I go to the second term, the negative 5, start distributing him. What's negative? And guys, somebody taught me this when I was first teaching, and I really liked it. I never did this. Instead of making this like laundry list of terms, watch this. When you go to the next distribution, negative 5 times 3x squared is negative 15x squared, right? Well, instead of writing that and making this big list, line them up underneath the other x squareds. And you're kind of setting yourself up where all of your like terms will be lined up. You just got to add them down. All right, negative, and you don't have to do that. I just really liked it when I saw it. Negative 5 times negative x is positive 5x. So put that under the other just x's, and then your like terms are really nice and organized. All right, and then negative 5 times positive 7 is negative 35, right? Just keep going here. He's the only just number, so he doesn't have a like term to be written under. And now when you go to clean this up, because I multiplied everything together, 6x to the third is my only x to the third, so he stays the same. My x squared, I had negative 2, but now I have negative 15 as well. So that's a total of negative 17 x squareds. And see, now we're back to where the exponents don't change when you're combining like terms. My x's, I had 14, I added 5 more, now I got 19 x's. And then my number is negative 35. He's the only one, so he stays the same. And there is your simplified polynomial expression. So guys, we're getting some pretty big answers, but the math we've all done, we've all distributed, we've all FOILed, we've all multiplied and added our exponents, okay? Everybody still good? Home, we're good? Thumbs up, we're all right? All right, so guys, look at the last one. Holy crap! Now you're taking 3-term polynomial and you're multiplying it with another 3-term polynomial. So you're not done until you've taken every single one of these pieces and multiplied it with every single one of them. So it's just total, distribute, distribute, distribute. All right, here we go. First term, all over there. Negative x squared times 4x squared. Negative 1 times 4 is negative 4. X squared times x squared is x to the 2 plus 2. Add your exponents, x to the 4th. All right, go to the next one. Negative x squared times positive 3x is going to be negative 3. X squared times x is x to the 3rd, 2 plus 1. One more. Negative x squared times positive 1. Well, guys, anything times positive 1 is itself. That's a negative x squared. Okay, so I have successfully multiplied the first term with everything over here. Now we go to the middle term. Now you take negative 5x, start distributing that. What's negative 5x times 4x squared? Negative 20, x to the 3rd, right? So put it under your x's to the 3rd. Start lining those combined like terms up. Bless you. All right, now we take negative 5, go to the middle term. Negative 5x times 3x is negative 15x squared. So put that under your x squares. One more. Now you got 5x times positive 1. That's negative 5x. Okay? One more. Now you got to take the positive 2 and distribute him to everything over there. So 2 times 4x squared is positive 8x squared. So keep lining your like terms up. 2 times 3x is positive 6x. And then last, 2 times 1 is 2. And now we clean it all up. X to the 4th, these are my only ones, so they stay the same. Negative 4, x to the 4th. My x's to the 3rd, I had negative 3, I got negative 20 more. That's a total of negative 23 x to the 3rd. Woo, I got a lot of x squares. I had negative 1, I added negative 15, now I got negative 16. But then you added 8, so that's negative 8x squareds now. When you add all 3 of those numbers up. My x's, I had negative 5, I added 6, that leaves me with 1x. And then my only number is 2, so he stays the same. And there's your simplified expression. So again, I hope you're sitting here thinking like, man, this is easy, but it's long. And it is. All right, that takes a little bit of time, and clearly you could easily make a mistake. So you want to be really, really careful with your math. All right, the last one. I'm not even going to do it all the way out. I just want to remind you guys, we did this before when we were foiling. I just want to warn you guys, Now that you're coming out of all those exponent rules, when we used to see that power of 2 with the exponents, we just distributed him in, right? You can't do that when it's involving adding and subtracting. So remember, when we were back foiling, the way we did this problem, since you can't distribute the 2, think about what it means to square something. If I'm going to square something, I have to times it by itself twice. So this was a write it twice, 4x minus 7 times 4x minus 7, and then it's a FOIL. These are FOILs in disguise. You write it twice, you FOIL it out. Write it twice and FOIL. I used to call those are the FOILs in disguise. Because coming out of those exponent rules, so many students want to start distributing, and you can't do that. All right, guys, everybody okay here? I did not create a homework for tonight. We're going to try and coast through this week, get to spring break, all right? So tomorrow in class, I'm going to let you do what I would have given for homework tonight, all right? So we'll have a quick Google Meet tomorrow, and then I'll let you guys start working on the homework. And please let me know if you are confused with anything. All right, let me double check your attendance, and you guys are going to be good to get out of here.